Hello mathematicians, we're now going to have a look at summing an arithmetic series or an AP. So the sum of the first n terms, which is sometimes referred to as the partial sum of an AP, is given by this formula. So we have the number of terms divided by 2, and this is our first term and this is our last term. Now we don't always know what the last term is, but we do know that the last term, the nth term, is given by a plus n minus 1d. So if we substitute a plus n minus 1d for L, then this gives us probably the more general equation for summing an AP, which is n on 2 outside of 2a plus n minus 1d. We can also use partial sums to recover the general term, since the general term is the expression for the sum of n terms minus the expression for the sum of n minus 1 terms. Or we can get particular terms. So if I wanted to know what the 56th term was, for example, and I knew the sum of the first 56 terms and the sum of the first 57 terms, clearly the 56th term is the difference between the two. Or actually, sorry, 56 and 55. Now, some typical questions. So, first one, add all the integers from 100 to 200 inclusive. So, first step is to realise we're talking about an AP with 100 as the first term, and then 101, 102, all the way up to 200. So, A is 100, the last term is 200, and we want to know how many terms we've got in between if we're going to use this formula, that the sum of n terms is n on 2 outside of a plus L. So we actually have, from 200 down to 100, we have 101 terms. So it's 101 on 2 outside the first one, 100, plus the last one, which is 200, whatever that works out to be. Another possibility, and I'm not encouraging this, is that you could find the sum of the numbers from 1 up to 200 minus the sum of the numbers from 1 up to 100. And that would give you the same answer. In the second example, given this AP, which clearly has a equal to 40 and d equal to minus 3, find S10 and an expression for Sn. So S10, if we use the n on 2 outside of 2a plus n minus 1d equation, will be 10 on 2, which is 5, outside of 2a, so that's 2 40s, plus n minus 1, which is 9, times the common difference, which is minus 3. So we evaluate that number. An expression for Sn just means that we take our equation up above, n on 2, we put in our values for 2a, so 80 and n minus 1 times minus 3, and we simplify that. And then to find our first negative partial sum, that means that we want the biggest value of n for which Sn is less than 0, for which Sn is a negative. So that is, we want the biggest value of n for which this, which is that equation adapted for this series, is less than 0. So we now set out about solving that. So multiply through by 2, and that will give us this. And then we know that the critical values, if you like, are n equals 0 and n equals 83 on 3. So we get 27 and 2/3. Now if we think about this expression here, we know that's a parabola, concave down, so it goes like this from 0 to 27 and 2/3. We want where this parabola is negative, so it's down here, which makes no sense in terms of adding terms up. And the first term, so the first integer value of n past 27, is then n equals 28. Now continuing on, the third one, the sum of the first 10 terms of an AP is 0, and the sum of the first and second term is 24. So they've told us two bits of information, so we should be suspecting simultaneous equations here. So our first piece of information, we take our formula for the sum of n terms, and we want the first 10 terms. So n is 10, so we plug n is 10 into our equation. We get 5 times that equals 0, so obviously that, 2a plus 9d is 0. And then the sum of the first and second term is 24. Our first term is a, our second term is a plus d. So that means that 2a plus d has to equal 24. Here we have our two equations to solve. So if we subtract 2 from 1, that will give us 8d is negative 24. So the common difference is minus 3. And if we plug that minus 3 up into well, it doesn't matter. Plug it into 1, we'll get 2a minus 27 equals 0, so 2a equals 27, a equals 27 on 2. And therefore our first three terms will be a plus d, which is 27 on 2 minus 3, so that's 13.5 minus 3 will 10.5. Silly pen. 10.5. So 10.5 and then minus another 3 to give us 7.5. And last example, given that Sn is n squared, find the formula for the nth term. So this is our expression that the nth term is the sum of the first n terms minus the sum of the first n minus 1 terms. So the first n terms add up to n squared. The first n minus 1 terms will add up obviously to n minus 1 squared. So we simplify this, n squared minus n squared plus 2n minus 2. So that gives us 2n minus 2 as the formula for the nth term. So at this point, what's the key idea in this section about adding an AP? And I'm sure you'll agree that there's not too much to it. Probably the two expressions are what we need to know and, more importantly, understand.